we're going to take a look at partial fractions. So say you had an example where you had to simplify this into a single fraction. So you're just going to do what you normally do. So you have x plus 1 over here, and that's multiplying with 1, and minus 1, and x minus 1 over here, divided by x minus 1 times x plus 1. And this simplifies to 2 over x minus 1, x plus 1. So that's how you really solve this when you're trying to simplify two fractions. But what if we want to go back to those two fractions? Well, these two fractions are called partial fractions. So this is what we're going to be dealing with. And the reason why we split any fraction into partial fractions is that it makes it easier for us to use binomial expansion, and it makes the integration easier as well. So now we're going to take a look at how you're going to decompose this fraction into partial fractions. So to start with, we're just going to write 2 over x minus 1 times x plus 1. And this is all identical to a over x minus 1 plus b over x plus 1. So what you're going to do now is that you're going to multiply both sides with x minus 1 and x plus 1. And if you multiply, the first fraction, the simplified fraction, is going to have its denominator cancel out whatever we multiply. So we're just going to have 2 over here. And for a, we're just going to cancel out x minus 1. So you're just going to have x plus 1. And for b, x plus 1 is going to cancel out. So you're just going to have b times x minus 1. So what you're going to do now is that you're going to find a value of x that will cancel out either of these coefficients. And so with that, we could easily just find the value of a or b. So in this case, what if we had x plus 1 was equal to 0? This means our x will be taken as minus 1 for now, and you're just going to plug this back into the 2. And we can clearly see that minus 1 plus 1 will just be 0. So now you're just going to have 2 is equal to negative 2b. So you can cancel the 2 out and take the negative sign to the left hand side, and you're just going to get negative 1. B is equal to negative 1. Likewise, you can do the same for x minus 1. So you have x minus 1 is equal to 0. X is equal to 0, 1. And if we plug this back into x minus 1, you're just going to get 0. And 0 times b is 0. And if we plug 1 into x plus 1, you're going to get 2. So you have 2 equal to a, and your value of a is just 1. Now that was just one example, and now I have to explain the difference between a proper and improper fraction. So improper fractions, the numerator's highest degree is less than the denominator. So if you could see here in the first example, the highest value, the highest degree of x is 1. And if you multiply these two brackets, the highest degree we can get is x squared. So clearly this is a proper fraction. Likewise over here, your highest power of x is 2. And if you multiply x times 3x times 9x, you're going to get 27x cubed. So this is also a proper fraction. And likewise over here, 7x has a degree of 1. And if you multiply x squared with x, you're going to get x cubed. And hence, this is also a proper fraction. In improper fraction, your highest degree is equal or greater than the denominators. So what that means is that in this first example, the degree of the numerator is 2. While if you multiply the denominators, 2x times x, you get 2x squared, where your numerator and denominator have the same degree, which means this is an improper fraction. And since you have an x cubed here, this means that the highest degree of power in the numerator is 3. And in the denominator, you have 3x squared times 4x, which is going to give you 12x cubed. So they're equal again. And over here, you have x cubed on the numerator, so degree is 3. And 7x times 2x is 14x squared. So the degree of the numerator is greater than the degree of the denominator. So these are some ways you will be tested on partial fractions. So this type is generally strange to a lot of people because the format for this is plus 1 plus b over x minus 1 and c over x minus 1 whole square. So what we have to do now is that you're going to multiply both sides with this. So now you're going to multiply with the denominator of the fraction that you're trying to decompose. So now you're going to get, so 1 is identical to a, and since we're multiplying x plus 1 times x minus 1 whole square is it's going to cancel out x plus 1. So now you're just going to have x minus 1 whole square. And you have, and with b, once you multiply with this expression, you're only just going to cancel out with only one of the x minus 1 bracket. So now you're going to have x plus 1 times x minus 1. And for c, you're just going to cancel out x minus 1, the whole square. So you're going to get it c times x plus 1. So now what you're going to do first is, for a, we're just going to say, okay, x minus 1 is equal to 0, x is equal to 1. And if you plug this back into a, you're going to get 0, which ultimately means there's no a. And for b, if you replace x with 1, you're going to get b times 2. But in the second bracket, you're going to get 1 minus 1, which is 0. So you're going to get 0 here again. So the only unknown number that is going to remain is c. So you're going to have 1 is equal to 2c, and c is equal to 1 over 2. So now you're going to take x plus 1, because that's the other one we see here. So x plus 1 is equal to 0, and x is equal to negative 1. And for a bracket, you're going to get minus 1, which is then square, you're going to get 4. So we're going to keep 1 is equal to 4a. But if you replace the first bracket of b with negative 1, is going to be 0. So we're going to forget about this as well. Same goes for c. You're also going to get 0 if you replace x with negative 1. So your value of a is equal to 1 over 4. So how are we going to find the value of b? Well, so we're going to take a random value of x other than 1 and negative 1. So let's take x equal to 0, for example, because that makes things easier. So you're going to have 1 is equal to, since our a value is 1 over 4, you're just going to have 1 over 4 times 0 minus 1 squared is just 1. And now you have plus b. 0 plus 1 is 1, and 0 minus 1 is negative 1. So you're going to multiply the whole thing with negative 1. So b times negative 1. And since our c is 1 over 2 plus 1 over 2, 0 plus 1 is 1. So now you have 1 is equal to 1 over 4 minus b plus 1 over 2. So now you're going to take 1 to the right hand side and b on the left hand side. So you're going to have b is equal to 1 over 4 plus 1 over 2 minus 1. And this all simplifies to negative 1 over 4. So now what you can do is replace a, b, and c with the values you've just found. So you have 1 over 4 x plus 1 minus 1 over 4 x minus 1 plus 1 over 2 x minus 1 whole square. So this is how you're going to write your final answer. So now you have a type 3 related to partial fractions, which is the denominators with the quadratic factor. X squared plus 1 is just going to give you a complex number, because x squared plus 1 equals 0, x squared equals negative 1, which doesn't have any real solutions. Hence, we're just going to have a quadratic factor within our partial fraction. So what you're going to do now is, instead of saying a over x minus 1 plus b over x squared plus 1, you're going to have bx plus c. And I'm going to explain this in the y section of the video. So you're going to multiply the whole thing with the denominator of your simplified fraction. So you're going to get 5x plus 1. So x minus 1 is going to cancel out. So you're just going to be left with x squared plus 1. And for bx plus c, you're just going to have bx plus c multiplied with x minus 1. So here you can also use the same method, but first we're going to look at this one, because this is easier to deal with. So you're going to have x minus 1 is equal to 0, and x is just equal to 1. Now be careful, you also have an x value on the left hand side, so you're going to take that into consideration as well. So what are you going to get is 5 times 1 plus 1 is equal to, so in the bracket you're going to have 1 plus 1, and that's just 2a, And since x minus 1 was equal to 0, this will just be 0. So you only have 5 times 1 plus 1 is equal to 2a, and it's pretty much equal to 3. So what do we do now? Well, you could just work with this bx plus c, because if you have x is equal to 0, you wouldn't have to be dealing with an extra unknown number because you already have your a known and c is what we want to know next. So we'll take x is equal to 0, and now we have 5 times 0 is 0 plus 1 is equal to, since a is 3 times 0 plus 1 is just 1, and since b times 0 is also going to be 0, you're just going to have c times 0 minus 1, which is just negative 1. So now you're going to get c is equal to 2. So how are we going to deal with x squared plus 1? What value of x should we put so that we get 0 and hence we don't have to deal with that? Well, there really isn't a way, because any number that is going to be squared is always going to be positive. So trying to find that value of x is going to lead to nothing. So what are you going to do instead is that, just like we did in our previous type, we're just going to take another random value. So in this case, since we already have 1 and 0, we're going to take something else. So let's say we take negative 1. So now you're going to get b is equal to negative 3. So now you're going to represent this as 3 over x minus 1 plus minus 3x plus 2 over x squared plus 1. So regarding the type 3 in partial fractions, we've seen this bx plus c format, and I'm going to explain to you why this sort of comes about. And the reason being is that once you note is that when you look at the highest degree of the numerator and the denominator, you can clearly see the degree of the numerator is less than the degree of the denominator. So we can clearly say that this entire thing is now a proper fraction, and that is pretty much our goal. We need to break our fraction down into more simple partial proper fractions. So that's our goal here. So now what you're going to do is that you're going to multiply both sides with 4x, x squared plus 6, and you're going to get 28x minus 3x squared minus 18 equal a x squared plus 6 plus bx plus c times 4x. And now you're going to say that x is equal to 0. And you're going to get negative 18 equal 6a, and a is just equal to negative 3. So some of you might have noticed that once we have taken x is equal to 0, b times 0 is always going to be 0. So if you remember from our previous example as well, to find c, we had to take x is equal to 0. So what do we do now here? So what this means is that we're going to use simultaneous equations somewhere in our working. So we're going to take x is equal to 1. We'll get 28 minus 3 minus 18 is equal to 7a plus, and since a was negative 3, so we're just going to replace that plus b plus c times 4. And you're going to get 28 is equal to 4b plus 4c, and you could just simplify that, but I won't. And now you're going to take x is equal to 2 and replace x values again. You're going to get 56 minus 3 times 4 minus 18 equal negative 3, and 2b plus c, 8, and review. So you're going to get 7 is equal to 2b plus c. So we're going to take c is equal to 7 minus 2b. So now you're going to replace c into 1, and what you're going to get is so as you notice, you can get b is equal to 0 in type 3 questions. So now we're going to have to find c, because it means that c is the only thing that exists over there. So in that case, you're going to get c is equal to 7 because of this expression. So we're going to take a look at the type 2 of decomposing into partial fractions. And over here, you could see that we have x minus 1 as one of our factors and x squared as one of our factors as well. X squared cannot be reducible. We're going to take this as an irreducible quadratic. So in that case, we're going to get a over x minus 1 And as we've said before, that our degree of the numerator should be less than the degree of the denominator. So you're going to get bx plus c over x squared. As you can see, we could split this into two separate fractions because of the addition. So you're going to get a over x minus 1 as it is. And now you're going to have bx over x squared plus c over x squared. And now you can simply cancel out one of the x from the fraction of b. And now you just have a over x minus 1 plus b over x plus c x squared. This is pretty much the same format that you would use for type 2 questions. And you might wonder, can't you just use that sort of format? And the answer is yes, you can. But instead of just writing x there, you're going to write whatever that square is. So what I mean by that is, say you had y plus 2 and y plus 8 squared. So what you're going to get is a over y plus 2 plus b times y plus 8 plus c over y plus 8 whole squared. And then split this into b y plus 8 over y plus 8 whole squared plus c over y plus 8 whole squared. And you can simply cancel that out. And it's better that you just write this format as it is without the whole deriving part. So these are the formats you're going to be working with as per the proper partial fraction questions. So for type 1, which is when you have linear factors with no repetition, you're going to use a over px plus q plus b over rx plus s format. And for type 2, where you have a repeated linear factor, you're just going to, in simple terms, build up the power for the repeated linear factor. And for type 3, you're going to use this format where you're going to be dealing with the irreducible quadratic factor. So you're going to be making sure that the irreducible quadratic factor has a numerator with x that has a degree less than the denominator. So now we're going to take a look at improper fractions and how we're going to decompose it into partial fractions. Now, as for your syllabus, you're not going to be dealing with questions that have the degree of x greater than the degree of x in the denominator. So here's one of the examples, x squared plus 3 over x plus 1 times x minus 3. So you might straight away say, okay, that's just a over x plus 1 plus b over x minus 3. And this is a mistake because you have to realize that if we multiply both of the x, you're going to get x squared. And since that is equal to the highest degree of the numerator, we must do something different. So usually to solve these sort of questions, what they do is that they use polynomial division. So you're going to have x squared plus 3 as your dividend and x plus 1 times x minus 3 as your divisor. But that is going to take awfully too long. So instead, what you're going to do now is that you're going to multiply these two x values. You're going to get x squared. So you're going to divide the x squared of the denominator with the x squared of the numerator. So in that case, you have x squared over x squared, which is 1. So in this case, your a is equal to 1. So now what we're going to do is multiply the whole thing with x plus 1 times x minus 3. And you're going to get x squared plus 3. So we're going to do the same procedure as we have done earlier. We're going to take x is equal to 3 and now we're going to take x is equal to negative 1. So now you decompose this fraction into 1 plus, actually minus 1 over x plus 1 plus 3 over x minus 3. And this is going, and for this question, you're going to do the same sort of logic. You're going to have one unknown number as it is without it being a fraction. So we're just going to write a. Now in this case, you could see that is, and before we look at the repeated root, we're going to write a fraction that has 3x minus 1 in its denominator. So in this case, b over 3x minus 1. And now what you're going to do is get c over x and d over x squared. So like we have done earlier, we're just going to multiply these two x values and we're going to be getting 3x cubed. So now you're going to divide the numerator with the denominator and you're going to get 1 over 3. So your a is just 1 over 3. So now you're going to multiply both sides with x squared times 3x minus 1. So you're going to be getting x cubed plus 2 equal. So now you're going to replace values again. So for the first part, we have 3x minus 1. So we want that to be 0. So we want that to be 0. So we're going to get 3x minus 1 is equal to 0. X is equal to 1 over 3. So now whatever unknown value right now has 3x minus 1, we're just going to disregard that. So in this case, this is going to be 0. This is also 0, and that is also 0. So 1 over 3 q plus 2 plus is equal to b 1 over 3. So you're going to get b as 55 over 3. I know this looks a bit weird, but you just have to trust the process. So now we're going to replace x with 0 because we could cancel out. So now we're going to replace x with 0. So we could cancel this out. So that's 0. This is also 0. That is also 0. So you're going to get 2 is equal to negative d, which is pretty much d is equal to negative 2. So now we have found a, b, and d. The only one that's left is c. So what you're going to do for that is that you're just going to use a random value of x apart from 1, 3, and 0. So you're going to use 1. So you're going to get. So your value of c is negative 6. So now you pretty much decompose the original fraction into 1 over 3 plus 55 over 3, 3x minus 1 minus 6 over x minus 2 over x cubed x squared. So if you really want to check if you've done it right, you can just multiply all these fractions back together. So now in this case, we have a irreducible quadratic fraction. What I want you guys to do is just solve this on your own before I show you the working. So we're going to do this the same way we have done for the other two questions, but this time we're going to involve the type 3 format. So we're going to have a plus b, x minus 1 plus cx plus d over 2x squared plus 1. So now you're going to multiply these two, you get 2x cubed. X cubed divided by 2x cubed is equal to 1 over 2. Your value of a is equal to 1 over 2. So now we're going to multiply both sides with the denominator of the left hand side, and we're going to have x cubed is equal to a, which is 1 over 2. So 1 over 2 times x minus 1, 2x squared plus 1 plus b, 2x squared plus 1 plus. So now you're going to have x is equal to 1. So you're going to cancel out this. So you're going to cancel out this and that. So we have 1 is equal to d3. So your value of a is equal to 1 over 3. And now we're going to take x is equal to 0 to remove this. So now we'll have 0 is equal to 1 over 2 times negative 1, 1 plus b, which is 1 over 3 times 1, and plus d, which is negative 1. And now you're going to get d is equal to negative 1 over 6. And now you can just take a random value of x apart from 1 and 0. And for this case, we're just going to take x is equal to negative 1. So now you're going to get negative 1 is equal to 1 over 2, negative 2 times 3 plus 1 over 3. So solving all of this, you're going to get c equal to 1 over 3. So now you've pretty much decomposed this into 1 over 2 plus b, which is 1 over 3. So 1 over 3 times x minus 1 plus c, which was 1 over 3, plus d, which is minus 1 over 6. So you're going to have 1 over 6 here, over 2x squared plus 1. And if we just simplify this, you're going to get 2 over 6x minus 1 over 6. And that's just pretty much 2x minus 1 over 2 over 2x squared plus 1 plus 1 over 3x times 3 times x minus 1 plus 1 over 2. And that is pretty much all the types of questions you're going to get regarding partial fractions.